Alright guys. So today we're going to start talking about antiderivatives of polynomial type functions. So we're going to take it slow and we're going to start off with these basic functions that we're getting antiderivatives of. And we'll talk about that process and what it's called and all that stuff, the name of the symbol, what it looks like. And we're going to go into all that information, okay? And then next week on Tuesday, we're going to look at finding antiderivatives of trigonometric functions. And then after that, we're going to look at solving differential equations using integration, using antiderivative. And then we're going to start doing some application type problems of this. And then we'll go on into some more in-depth stuff regarding integrals and all that good stuff. So right now, today is just the foundation, it's the basics. So it's important that you really understand this and you learn it well, okay? Alright, so let's see. I want you to write down what you feel are the inverses of these terms here. So what would be the inverse of 5? What do you think? -5. So I'm just going to write down what you say. There's no wrong answers. What is, do you feel is the inverse of 1/3? 3? Okay. There are no wrong answers. There are no wrong answers. What do you think is the inverse of boy? Girl? What do you feel is the inverse of dog?
Tiger.
Cat?
Tacos.
Cold dog?
What is cold dog?
Corn dog? Maybe corn dog?
What am I maybe hamburger? Yeah, like hamburger.
I'm
Burrito.
just gonna put cold cat. Yeah, cold cat.
Cool cat.
Okay. So if we think of the words boy, dog, and hot dog, those are all called what in English?
Words.
Nouns, right? Okay. So those are nouns. What do we say an inverse of something was, or what did it do to something? It cancels it out, right? So does a boy cancel out a girl? No. Does a dog cancel out a cat? No. Can we cancel out nouns? No, okay? We can cancel out actions, right? Things that we do, okay? And those are called what in English? Verbs. Oh, good job. All right. English to start. So, what it says here is that inverses are opposite what? Operations, not just what? Opposites, alright? So maybe that's why some of you said -5. And -5 is the inverse of 5 when you're adding, right? Okay, when I'm add 5 and -5, do they cancel out? Yes. Okay, but it's not the inverse of 5 when I multiply. Okay, what's the inverse operation of multiplication? Division, right? Okay, so I would have to multiply by 1/5, right? So just like there's different inverses depending on the operation, there's also different identities, right? What does the identity do to something?
That's the way it is.
Does it do anything to it?
No.
No. Okay, so for example, the identity through addition is what? What is it that I can add that will do nothing to the problem?
0.
0, right? What's the identity in multiplication? 1. Okay? Do you understand?
Yes.
Different inverses, different identities depending on operation that you're working. Alright, so we take inverses of verbs, not nouns. So let's look at these processes and see if we can write the inverse of them. So what would be the inverse process of sitting down? Standing up. Standing up, okay. What would be the inverse of getting dressed? Undressing? What would be the inverse of taking a book? What would cancel that out?
Throwing it at someone.
Return the book, not throwing it at someone. What would be the inverse of getting wet? Getting dry. Should I just put dry? Drying? What would be the inverse of going to sleep? Waking up. So do those cancel each other out? Yes, right? So we know that finding derivatives, which is called differentiating, is a process. It's an action. It's something that we do. Right, so it has to have an inverse, okay? And that inverse is called the antiderivative. And that's called anti what? Differentiating, undoing the derivative. Okay? So, do we remember how to find the derivative of a polynomial type function? So let's say I had this, 3x squared plus 2x. How would I find its derivative?
Power rule?
Let's write down the steps. So it says, if you had to explain to someone how to find the derivative, what would you say? What would be the first thing I do? Multiply. So multiply the coefficient. What's the coefficient? The number in front of the term, right? So 3. So multiply the coefficient of each term by what? By its exponent. Okay. Alright, so after I multiply, what do I do? So if this is y, then y prime we said would be 6x, and then this one would be plus 2, right? What would I do? Subtract what? 1 from the exponent. So this would become 6x plus 2, just like I said there, right? You take away 1 from 2, and 1 from 1 becomes 2. Easy? Alright, so to find the antiderivative, you do the opposite of each one of those operations and in the reverse order. Okay, so therefore, to find the antiderivative of a polynomial type function, what would we do? So we got to do the opposite of each one and in reverse order. So first, I would have to, instead of subtracting 1, I would what? Add 1 to the exponent. And then divide the coefficient of each term by its new exponent, right? What if we have a constant? So what would be the variable of something that had a constant? What could it technically be? X to the what power? To the 0, right? So if I add 1 to that, then I just get x. So when you're finding antiderivatives, you need to ask yourself, you look at the derivative that you have, and you say, okay, who would give me this derivative? So if you have a constant, right? Like let's say you know the derivative is 7, so you say, whose derivative is 7? 7x.
What if the original one had a constant?
We're going to get to that. Okay? Are we okay with the procedure here? Yes? Alright. So, it says, if y equals x squared, then what does y prime equal? 3x squared, right? Find the derivative, like normal, right? So what could we say? Blank is an antiderivative of blank. Who would be the antiderivative? X to the third, right? So that means x to the third is an antiderivative of 3x squared. Now why do you think I use the word an antiderivative? Could there be several? So this is going to what Robert was talking about. Could there be several? Why is it an and not the antiderivative? So if I had x cubed plus 2, would the derivative still be 3x squared? Yes? What if I had x cubed plus 5? Would the derivative still be that?
Yeah.
What if I had x cubed plus 6? Would the derivative still be 3x squared? right? So this is just one antiderivative, right? There could be how many? An infinite amount, right? Okay, so that comes to this question. So it says, since there is an infinite number of functions whose derivative is 3x squared, right? We must say that the antiderivative of 3x squared is x to the third plus some, what? C value that represents a what? A constant that could have been there. And that'll be the case for any function that we integrate. It could have always, or they could have all had some constant there that when I got the derivative of was 0, so it doesn't come out in the derivative. But I have to assume that there could have been one. Do we understand? Does that make sense or no? Yes? I have to show you. If I have x to the third plus 5, what's its derivative? 3x squared, right? But if I have x to the third plus 10, what's its derivative? 3x squared. So there's a lot of antiderivatives for 3x squared, right? Okay, all of them could have had some arbitrary constant c there. Okay, that's called the constant of integration. You have to put it there when we're doing this particular type of integration. You understand? Sort of? What does the c mean? Some constant. Alright, so this process of finding antiderivatives is called, anybody know what this process is called? It starts with an I. Integration. Okay, specifically the type of integration that we're doing here is called indefinite integration. Okay, that's why we have to put the C, because there's an indefinite amount of answers that we could get. There's also definite integration. That's what we'll use when we're trying to find the area under the curve from one point to another point. Cool? Yeah? But we'll get into that later. Right now we're just learning the basics. Alright, so this is the notation that we will use. We'll have this symbol here that kind of looks like an S for my last name. Okay, but it's not an S. This is actually the integral symbol. You ever seen that? Okay. Now it's going to have whatever we want the integral of, and then dx. So what this is telling you is that this identifies the independent variable. Okay. Later on, we're going to treat it as its own entity, its own term. When we start doing integration using U substitution and all this fun stuff. Yeah? What is all this going to be called? The antiderivative. So let's say here I had a velocity function. What would I end up with if I got its antiderivative? The position function, okay? So this is where integrals are important. What if I had the acceleration here and I integrated it? I would get the velocity function, and then I integrated that one. Position function, right? Now I would have to have more specific information to get the actual velocity function for a particular graph, because if I don't, I'm going to have this what? This constant here, okay? Do we understand? So if I would integrate it again, I would end up with another constant. Yeah? Good? Sort of, maybe? So let's do some examples here, okay? The main question you have to think about when you're doing integration is you have to ask yourself, okay, so let's say we're looking at this problem and I wanted to integrate it. What you need to ask yourself is, whose derivative would give me this? In other words, if I take the derivative of this function that I'm thinking of in my head, it would give me x. Okay, that's going to help you find the antiderivative. So remember that. Whose derivative is x? Okay? Or you can just follow the procedure that we said. So we have to add 1 to the power, and then divide by that power. So if we look at this one, what's the power of x here?
1.
1. So if I add 1 to x, what do I get?
X.
X squared, and then we gotta divide by it. Okay? Now, is this the antiderivative or is it an antiderivative? It's just one of them, right? Okay, so if I wanted the actual antiderivative, it would be the integral of x dx. That's going to give me 1/2 x squared plus what? Plus c. So who's going to be the honorary plus c reminder in this class? Any volunteers? To make sure that I don't forget to put plus c? Or that we don't forget to put plus c? You?
Yes.
Alright, so Alejandra is the honorary plus c reminder. So if we forget or we don't say it, Ale, you better say plus c, okay?
So if she forgets.
Got it? Yes? How can I check my answer, Andrea? What do you think I could do to this to see if I got it right? Find the derivative, right? So 2 times half? 1. Take away 1 from 2, do we get x? I did it correctly, okay? Do we understand? Alright, so try the next one. Let's do it. Okay, so what I like to do is I write the coefficient and I write the letter, and then I put the new power. So what would the new power be? 3, and then we're going to divide by that new power, so 3. Okay, so over here we're going to have the integral